Okay, we have a question here, and I'd like us to look at this question. First thing we want to, whenever we say question like this, it takes us back to understanding of indices, where we say a is raised to power x times a raised to power u. Because the base is the same, we have a multiplication, we add our powers. Now the a raised to power u, a raised to power x plus u. But if it's were division sign, what are we going to do? We subtract our powers. So if we're given this case, taking it to this, we just say a raised to power x divided by a raised to power u. And we have it in this. We have converted here to this. Now, if you look at this same question, it looks alike. So we come to that. We say 3 raised to power 2x minus 1. What does this remind us? 3 raised to power 2x divided by 3 raised to power 1. If you take the powers, you're going to have 1 3 raised to power 2x. Then, because it's division, subtract. If you take the base, you subtract your powers. This is what we have. So I can rewrite this in this form. So it's going to be 3 raised to power 2x divided by 3 raised to power 1. I can do the same thing here. Negative 28. This is what 3 raised to power x divided by 3 raised to power 2. There's a 2 here. If this were 2, this would have been 3 raised to power 2. If it were 7, it would be 3 raised to power 7. The same base. Nothing will change. Just the same base. So I think I'll go with that. Plus 1 equals 0. Now, one thing I want us to remember. One thing I want us to remember is that if I say a raised to power nx, I could rewrite this as a raised to power x times n. If I change this concentration of this power, it doesn't really matter. I could do that, and I'm going to do that for a reason, because of this case. Now, what do you do that? I'm going to change this to what? 3x or squared. 3 raised to power x whole squared. I can rewrite this in terms of a raised to power x or raised to power n. It's the same as this. It's the same. So I am putting this in this form. I'm going to do that same thing here. Remember, this division, 3 raised to power 1 is what? Is 3. Now, because we have division, we could say over 3. Then here, we could say 28. What do we have here? We have times what? 3 raised to power x divided by what? 3 raised to power 2 is what? 9. Plus 1 equals 0. Now, there was a reason why I did this. We're going to say let 3 raised to power x equals the letter p. Chose p. So when you see 3 raised to power x, you put p. So this is going to be what? P squared over 3 negative 28. This is p. 28p over 9 plus 1 equals 0. Can you see me from there?
Yes, sir.
Now, what do we do next? To eradicate the fraction, multiply through by what? The leading LCM. The LCM of the geometer, which is 9. If I multiply this by 9, what will happen here? I'll have the 9 into bracket p squared, right? If this cancels, you are left with 3, right? 3 times p squared, what will you get? 3p squared. Let me write it somewhere here. So the new formation, this will be 3p squared for the first case. Now, going to the second one, 9 cancel 9. That's going to cancel now. We're going to left with negative 28p. Then 9 times 1. We're going to get what? 9. Have you seen it? 9 times 1 is 9. 9 times 0 is what? 0. So this has left us a quadratic function. Now, what do we do in this case? 9 times 3 is what? 27. So we ask ourselves, what two numbers? Is it factorizable? It looks like. Because every quadratic equation is factorizable. Every. There's a special trick. There's a special method used in factorizing every function, no matter how complex it looks. I'll make a video for that maybe sometime later. Now, 3 times 9 is 27. So what two numbers if we multiply? Right? What two numbers if we multiply? Hmm? So the idea here is we want to solve for b, and this is a quadratic function at this point. 3 times 9 is 27. So we want to get two numbers that multiplies to give us 27 and adds up to give us what? Negative 28. And what are those numbers? Negative 27 and negative 1. It will give us positive 27, 1 multiply it. And for out of them, we're going to get negative 28, which is it. So we are good to go. P is what? Negative 27 and P is what? Negative 1. Now remember we have a 3 here. If it were just 1, we'll not divide by anything. Because dividing by 1 won't change it. But because we have a coefficient of a quadratic term as a what? A coefficient other than 1, you have to divide through by it. Do not forget this when you're using this method. So 3 in 27, we have P minus 9 and what? P minus 1 over 3 equals 0. Yes, can you see it from there? Yes. P, if you set each one equal to 0, if you set each of them equal to 0, if you set each one equal to 0, P will be equal to 9. Is it clear from there?
Yes,
P will be equal to 9.
yes, sir.
So what I did is that, for those that can't see, now, if you set each one equal to 0, P minus 9 equal to 0, because if these two multiplies to give you 0, then each of them should be equal to 0. If you set this equal to 0 and set this other side equal to 0, P will be equal 9 and P will be equal what? 1 over 3. P will be equal 9 and P will be equal 1 over 3. Okay, now we know P is equals 9 and P equals 1 over 3. But remember, recall, our 3 raised to the power x equals P. And now P equals 9. What are we going to do for our first case? We say 3 raised to the power x equals 9. That means what? 9 is what? 3 raised to the power x equals 3. 9 is 3 squared. So if 9 is 3 squared, if we cut this out, x will be equals 2 for the first case. For the second case, 3 raised to the power x equals what? 1 over 3. 3 raised to the power x equals what? Remember, we could take, if we take this number up, the sign will be negative. So it's going to go 3 raised to the power minus 1. At this point, if you cut out, x will be equal to negative 1. So x is 2 and x is minus 1 for that case. Thank you. Okay, if you understood this question and it's easier and it appears simpler to you from my explanation, please do follow me on TikTok. I'm going to drop my YouTube link on the description. Please like the video, subscribe, and follow my other activities. Thank you and God bless.